What we're going to do is talk about, now this phrase may seem like it's not that big of a deal, but it kind of is. What we're going to do, let's make this a little thicker. We're finding the distance between, whoops, how about an N, between a point and a line. Point and a line. You think, well, that's not that big of a deal. Who cares about that? But if you see this phrase right here, the distance between a point and a line, let's discuss the distance between a point and a line. So here's a line right here. And let's draw a point somewhere. Let's just draw a point like right here. All right, so there's a point and there's a line. And let's go to another color here. So what if I wanted to describe the distance between this point and this line? What would I do? Would I go to like right here? Would I go right here? Well, that's a straight line. Well, this is down and it's straight.
To make a right angle.
Okay, to make a right angle, that's a good start. Give me a word. I heard it. Perpendicular, okay? And you're absolutely right. When you say make a right angle, that's good. When you say straight down, that's what I was trying to get you to think a little bit more about, okay? Because look, that's a straight line, right? And it's going down. Would you agree? Right? So we don't say, but listen, we don't say straight down. I know exactly what you're thinking. I understand, okay? It's not like I'm like, oh, I don't know what you're talking about when you say straight down. I know what you mean by straight down. But we have to be on the same page. We have to be on the same page on this. We don't want to just say straight down. I'll show you another example where straight down doesn't always work. Okay? On this particular one, I know exactly what you're talking about. But what we're going to do is we're going to say it has to be what? Perpendicular. That's right. So this line right here is going to be perpendicular to the white line. So this is the distance. This red line right here, I'll call it D for distance. That's the distance between a point, if I could spell today, okay, a point and a what? And a line. That would be the distance. All right, what you're going to have to do, you're going to have several problems. It's very easy. I'm making this a lot easier for you than I normally would, because with the honors class we did this, and most of them really struggled, okay, with what they really want you to do in the book. I'm going to make it a little bit easier, but I still want you to understand what it means to find the distance between a point and a line. It's the perpendicular distance. Okay, so if you have some unknown point out here and you have a line down here, if I wanted to find the distance, it's perpendicular. For instance, I usually give like the example of flying in an airplane. All right, so here's my cool airplane right there. Look at that. Isn't that cool? Looks like a jet or something, right? And there's the pilot inside of there, okay? So there's your airplane. Who's been on it like a, like a, what do you call these planes? Like a big old plane, not just a little tiny plane, but like a commercial. That's what I was trying to think of. Like a commercial jet, like a like a big old plane, okay? I mean, I know, but I'm trying to get you.
Call it a big old plane.
We understand. It's okay. Keep going.
Okay. You've been on a plane. The pilot gets on there. The pilot gets on there and says, now we're cruising at 30,000. Or he always has that voice, doesn't he? Doesn't every pilot have the voice? Oh, thank you for flying Southwest. We're now currently cruising at 30,000 feet. Right? It seems like they always talk like that, doesn't it? It seems like you never get a pilot that said, "Hey, what's up? We're gonna," But he always has this cool, deep voice, But anyway, he's flying along and he says 30,000 feet. So what is he talking about? We're cruising at an altitude of 30,000 feet. Well, he's not talking about where you're gonna. I've missed this so much. He's not talking about this distance from where you're gonna land or the distance from where he took off. Okay. Or just some arbitrary point on the ground. Pretend this was the ground and this was the... What's he talking about? He's talking about that, what? That perpendicular distance, right? That would be the 30,000 feet. Would you agree? All right, so when he's talking about the altitude, you hear that word? A lot of times this distance right there, a lot of times they call this the altitude. Did I spell that right? Altitude, yep. They'll call this the altitude. So think about being in an airplane. When they said our altitude is 30,000 feet or 20,000 feet or wherever they are, that's the altitude. What is the altitude? The altitude is the perpendicular distance from that point to that particular line. This line would be like considered the ground level, okay? And their altitude is 30,000 feet, so it's the perpendicular distance. He doesn't get on there on the loudspeaker and say, okay, now we're at a perpendicular distance of, no, he doesn't say that. He says we're at an altitude. And so the altitude, the word altitude means the distance between the point and the line, okay? That's what you're talking about when you talk about an altitude. I don't think we're going to deal with it a whole lot in this lesson, but there are other lessons where we talk about the altitude. In fact, there's a whole other chapter. I'm trying to think of what number the chapter is. I can't remember exactly, but there is a chapter we're going to talk about triangles, and we will talk about an altitude. So when we talk about that, I might refer back. Remember that time we drew that dumb picture of the airplane, we did the pilot voice and all that, and the altitude is what? It's the perpendicular distance from that point to that line. Everybody with me on that? Now, a lot of you guys were saying it's the straight up and down. It's straight down. It's straight down. Okay, well, what if you had your line like this? What if it wasn't a horizontal line and you had some point out here like this? Now, can you just say, now I think you'll understand why I was kind of picky about not saying go just straight down. Because look, do I just go straight down to get from this point to this line? I don't just go straight down, do I? So you can't just say straight down, but I could say what? I don't just say straight across. What do I say? I say it's the line that's what? Perpendicular, right. It's perpendicular. Now, I'll probably have to guess. That looks kind of perpendicular, doesn't it? All right, if I put the little box there, that means it's perpendicular. So that right there is the distance between this point and this line. All right? You're going to have some problems. They're going to give you something like that. In fact, they might even have it in a triangle. Let me just look at the worksheet real quick. So if you just had some point just sitting there in some line, that would be easy to find the distance. And I would ask you, what would I actually ask you to do? I'd actually ask you to draw it. Let's say they call that point A, and they call this line L. And I said draw or construct. Sometimes they use that word construct instead of draw, but that's basically what it means. All right? But notice what I did here. Now, on my little program here, I've got a line tool, right, that I can make a nice straight line. All right, but what you should do, you shouldn't just take this point and just kind of squiggly like this, okay? You don't want to do that. You want to have a line. Either keep a ruler in your book bag or just take a piece of paper and fold it in half, or maybe you have an index card or something like that that you can use. But make a nice straight line, okay? Don't just take a point out here and say there, okay? I don't want you doing that. I want you to be a little bit neater about it and have a straight line. All right, lines are supposed to be straight, so get a straight line. So here's the kind of stuff they're going to ask you to do on this homework. It's not that hard. Let's go back to white, and so they might give you a triangle. We'll make the triangle look like this. And this bottom one doesn't have to be horizontal, okay? It could be tilted all kinds of ways. And they might say, let's label this triangle. Let's call this ABC. And they might say, construct the segment that represents the distance from, let's say, from point A to, let's say, line BC, or line segment BC. So what would you do? If you wanted to show the distance, construct a line that goes from point A to line segment BC. So do I just draw it anywhere on BC? Is that good enough? I have to draw it so it's what? Say it, Cookie. Perpendicular. That's right. I got to draw it from point A to line BC, but I can't just draw it anywhere. I got to draw it so it's perpendicular. So now you might have to eyeball a little bit. I'm not asking you to use a protractor or anything like that to see that it's 90. That's pretty close to 90, don't you think? About right in there. Now, how would I just do that? Is that all I would draw? I would draw the right angle, because the right angle means it's perpendicular, okay? And it must be perpendicular. So that would be your answer. Here's your question. Your question is, they give you a triangle, they label the points, and they say, construct a segment that represents the distance from point A to line segment BC. So you start at A and you go to BC just like that. Or they could ask you what? Go from, let's say, point B to what? Where do you think? Can you go the distance from B to like A or B to C? B to what? AC, that's right. So you would construct a perpendicular from B that goes to AC. Does that make sense? All right. They might give you, let's do another one. They might give you a quadrilateral. In fact, we'll talk about this in another chapter, but this is actually a parallelogram. But let's do this. Let's, what do I want to do? Shear, I think. And let's go like 30 degrees. And that makes it look like that. Okay? And let's put some points on here. We'll just use the ABCD thing. That's an ugly B. Let's try it again. Here we go. All right. Now, what are they going to ask you? They could ask you several different things. But let's say they say construct the segment from point A to line segment DC. All right? You hear what I said? Construct the segment that represents the distance from point A to line segment DC. So what would I do? I'd start at A, and where would I go? Here, here, where? Perpendicular, that's right, perpendicular to DC. Now don't just leave it like that, because if you just left it like that, I'd have to mark it wrong if it was a quiz or a test. All right? If this is the distance, it has to be perpendicular to the line that it's hitting. So you have to put that little box right there. If you don't put the box right there, guess what? Talk to me, come on. It's wrong, that's right. Okay? That's right, it's wrong. Okay? So it would be wrong if you didn't put the box there, because the box indicates that you have a perpendicular line. What if, let's make this a little bit different. What if I asked you to go from point D, or construct a segment from point D to line segment BC? That might be a little bit different. If I go from D, let's make a little line thing, to go to BC, do I just put it right there? Do I just put it right there, right there, right there?
Yeah, just go over C.
Yeah, because there's no way it's not perpendicular anywhere along here, is it? So what would I have to do to BC? You said continue it. What's a word that, I think we might have used this before. Extend it, right, extend BC. So let's forget about that line right there. Let's just do this. See if I can extend it. All right, and they usually show extending the line with a dotted line. I'm not using a ruler or anything, but that's pretty close. Okay, so see what I did? I took BC. So now, when I start at D, now I have a place to land my little segment. Okay, and probably about right in there. Does that look perpendicular? Maybe about like that. I'd say about right in there somewhere. Now, is that enough? No, I got to do what? Put a little perpendicular symbol thing there. You got it? And so that line right there is the distance from point D to line segment BC. Everybody see that? That's all you have to do. There's no math involved. All you have to do is draw it. But I want a straight line. I don't want a squiggly line. I want a nice straight line. Use a ruler. Use a piece of paper folded in half, you know, to trace across. Use a cardstock. What did I say before? Index card. Okay, to use something like that to give yourself a nice straight line. And then you must have a little perpendicular. It looks a little curved, but you get the idea. It should be straight up and down like this, okay? So that's all you're going to do. So the first three problems, that's what you're going to do, okay? Seems pretty easy, doesn't it? Yeah, it should be. Okay, shouldn't be anything real difficult about that. All right, let's look at another type of problem. All right, now this next part is a little bit, it's kind of like what we just did, but with a little bit of a twist, okay? You might have to use graph paper on this to get fairly accurate. You really don't absolutely need graph paper on this, but it might be helpful to you. So watch what they're going to do. They're going to say, let me find a good problem here. I don't want to use the one from the example. All right, let's use this one. What we're going to do is we are going to find the distance. Or we're not really going to find it because that gets real complicated. What we're going to do is just draw it. Okay, I'm just going to have you draw it. But you do need to be fairly accurate. So what I want you to do is I want you to draw the distance from, actually let's write the whole thing out. Now on the worksheet that I'm going to give you, it says find the distance, which means they want an actual number for this. I'm not looking that you give me an actual number. I'm just looking that you can draw it the correct way from a certain point to a certain line. Okay, that's all I want you to do. So I want you to draw the distance or construct. Let's say construct. You won't see those words on the paper. You just have to look at it and said, okay, Mr. Hamrick said, don't find the distance, construct the distance. Means just draw the picture. Everybody understand that? All right, so when you get this worksheet and it says find the distance, don't look at it and say, how am I supposed to find the distance? How am I supposed to do that? All you do is construct it. Draw the picture, okay? So construct the distance from, now they're going to give you some points, from 4, 3, the point 4, 3, and that's point P. We'll put a P in front of it, point P. So there's your point, and we want to draw a perpendicular from this point to a particular line. And here's how they give the line. They give the line as an ordered pair. So the line goes from 0, -3 to 7, 4. Okay? So how do we do this? Well, let's draw an X and Y axis. And you can do this without graph paper. You don't really need graph paper for this. But let's draw the points. Let's draw that point 4, 3 first. So 1, 2, 3, 4, and then 1, 2, 3. Let's put a point right there. We'll do that in red. So there's 4, there's 3, and that's point P. I want this labeled. Okay, I'm not asking you to do any math with this. All right, so I'm not asking you to do a whole lot. I am asking you, though, to label the stuff correctly. So that's point P. Now, what's this thing right here? Well, this is a line, isn't it? They're 2 points, and I can connect those 2 points to get a line. So let's draw that line right there. And keep it all color coordinated. 0, -3. So I go 1, 2, 3 down here. So that's going to be a point. There's 0, -3. And then 7, 4. So I'm going to have to count over some more. So I've already gone, what, 1, 2, 3, 4, 5, 6, 7. And 7, 4 would be about right here. All right, and let's make that red as well. So there's 7, there's 4. So far, pretty easy, isn't it? What did I do? I just plotted all 3 of those points. Now, which one's my line? Do I connect this one to P? No, I connect this 0, -3 to this one right here, 7, 4. So I'm going to get my line tool and just connect them like this. All right. Now, don't start it and stop it there. Make it go out a little bit more. Everybody with me so far? So now, that's what you need on your paper so far. But, oops. But what do I have to do? I want to construct the distance from this point to this line. So how do I do that? I go from here, where? Not parallel. Perpendicular. Perpendicular to this line. Now, how do I know exactly if it's going to be perpendicular or not? Well, what can I find on this line right here? I can find the what? What's true about 2 lines that are perpendicular? We've talked about this before. The slopes. What about the slopes? Okay, they're negative reciprocals of each other, aren't they? Okay, so let's do this. Let's find the slope of this line right here. Then we're going to be able to find the slope of this line. Okay, and then I'll know if they're exactly perpendicular or not. I'm not just guessing. I'm not just looking at it and saying, nah, it looks perpendicular from here to here. I want to know exactly that it's perpendicular. So let's find the slope of this line right here. Well, how do we find the slope? It's the change in y over the change in x. How do we find the change in y? We subtract the y's from each other. So it's -3 minus 4. Those are my y values. Remember this, right? This is on the last quiz. Or did we do this in this chapter? Probably did in this chapter, right? So -3 minus 4, and then 0 minus 7. That's my x's. 0 minus 7. So what do we get? -3 minus 4 is -7 over -7. What's -7 over -7? It's +1, isn't it? So that's the slope of this line. So what's the slope of the line that I want to find? What's the slope of my new line? It's going to be what? It's going to be -1. That's right, because it's the negative reciprocal. We change the sign, okay, and we flip the fraction. If I flip the fraction, still is 1, isn't it? Okay, if I change the sign, it becomes negative. So now how do I find the slope of this? Rise over run. So I rise. Where are we right here? This is 4, 3, right? I rise -1, so I go down to 2. And then where do I run? Over 1, right? And that would be right there, wouldn't it? So there's my other point. What do I do with those 2 points? Just connect them, right? Actually, let's just go from point to point because we're finding the distance, aren't we? So that little thing right there is the distance from this point to this line. I didn't just guess where that point was, did I? And so here's what I want you to do. I want you to tell me exactly where that point is. So if I was here at 3 and I went down 1, Now I'm at where? 2. And I go across, where am I here? This was 1, 2, 3, 4, so where am I? So what's this point right here? It's 5, what? 2. 5, 2. Because this was at 3, wasn't it? This went down 1, right? Everybody see that? So that point right there is 5, 2. That's what I want you to find. Okay? Does that make sense? That's what I want you to do. I want you to find that point. So I need that labeled. You should label this one as well. We already know that. That was 4, 3. You should label this one. All right, so all these points that you're putting on here, I want you to label them. Don't just let them sit there in the middle of nothing. All right, I want you to label these points. So what am I looking for an answer with this? Believe me, I'm making this a lot easier than what I had the honors class do. I'm making it a lot easier. So what do I want? I want this labeled and this labeled. That's not hard, is it? You just take the 2 points and label them. I want this one labeled right here. Okay, what was the hardest part, though? The hardest part was to find this point right there, wasn't it? All right, that's what I want you to do. I want you to rise and run, figure out what that point is, and then you're good to go. All right? Now, if you wanted to, you could have risen. You could have gone. Your slope could have been like -2 over +2. That's still -1. Could have been -3 over +3. It doesn't have to be right here, but that line right there is a nice straight line, okay? And it's perpendicular, so I'll put the little perpendicular symbol, and I'm done. All right? Let's do another one. We got time. Let's do one more like that. Now, at first, when the first time you see something like that, you get a little confused, but after we see it the second time, it should start making some sense because you kind of know what we're going to do. All right, so let's see it a second time, and it should help you out a little bit. Let's do another one. All right, here's point P again. They still use point P, and this time it's 5, 7. So there's your point. Now your line is -2, 1 and 4, 1. All right, so that should make it kind of easy. Watch. So let's plot the points. 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. All right, so 5, 7. Let's do this in yellow this time. So, right, there's 5, there's 7, and there's our point. Everybody can do that, right? What else do I plot? We'll put this P. We'll make this P, and we'll even put 5, 7 right there. Label everything. Let's label the other. Let's plot the other 2 points. -2, 1. So let's do that. -2. +1 would be right here. And let's make this yellow. So -2, 1. That would be 1 point. Let's label it. -2, 1. Let's label the other point. 4, 1. It's already got enough things here. 1, 2, 3, 4, 1 would be right there. Okay? And what are we going to do? Connect these two, right? And I'm going to just extend it out a little bit more than I might need it. And let's label this point right here. That's 4, 1. A little small, but that's a 4, 1 right there. Everybody okay? Anybody taking notes on this? I only see like 3 people writing. Now, what are we trying to do? We're trying to find the distance from point P to this line right here. Well, what's the slope of this line right here? It's 0, right, because it's a horizontal line. So what's the slope of this going to be? What's a perpendicular line? It's going to be undefined, so it's going to be what kind of a line? If this is horizontal, this is going to be what? It's going to be vertical, isn't it? So that's pretty easy. So I just draw a vertical line straight up and down right where it hits. Now, where's that point where it hits? Where's that point, that red point? How far over do we go? 5, and how far up do we go? 1. So that point right there is at 5, 1. Okay? And that's what I want. Got everything labeled, don't I? Got this point labeled, got these 2 lines labeled. There's my perpendicular. I got the point right here labeled, and I'm good to go. And that's all there is to it. Think you can handle that? All right. Let's try another type. This time, they're not going to give you the points. They're going to actually give you the equation of the lines. Okay? They're going to give you 2 lines, but they're going to give you the equation. Actually, let me see first of all. Oh, I should have said that. Let's do this first before I do this problem. Okay? We still got some time, so hang on. What if I ask you this? Now, we learned how to find the distance between a single point and a line. But now what we're going to do is we're going to find the distance between, what do you think? Two, not just any two lines, but two what? Two parallel lines. That's right. So these two lines are parallel to each other. So what do you think? You could start at any point here. I don't care. Start at a point. Let's do this in another color. Go green. Let's put a point right here. What would be the distance from this line to this line? Pick any point. Doesn't matter which point you pick. Okay, pick one right there. Would it be from there to there? Would it be from there to there? Talk to me. It would be what? It'd be perpendicular again, wouldn't it? Okay, it's kind of like going from a point to a line, isn't it? We just picked a point on that line somewhere. So make it look perpendicular right there, and put the little perpendicular symbol, and there you go. That is the distance. That green, is that a little green up there? Yep, it does. Okay, that green right there is the perpendicular. It's the distance between those two lines. Because look, you wouldn't do this. What if, would that be the distance between the two lines, or that? I mean, you got to have some kind of a way to make it consistent, don't you? Look at that. What if that was perpendicular? Is this length any different than this length? Not at all. All right? It's the same distance, isn't it? All right? As long as you go perpendicular from one line to the other, those lengths are going to be exactly the same. Make sense? Okay. So now let's do this. Let's take two lines that they give you, and we're going to draw the distance between those two lines. Now, they're not just going to give you any two lines. They're going to give you two lines that are perpendicular. Because watch this. What if you had a line like this and a line like this? Is there one distance between those two lines? If you think about it, no, there's not. Because look, if I went from this point perpendicular to this one, that wouldn't be the same. Let me do this. That wouldn't be the same distance as here to here, would it? Even though they're both perpendicular? Would you agree? See, look, they're both perpendicular, but are these two distances the same? No, they're not. So what must have to be true about your two lines? They have to be what? They got to be parallel to each other, okay? So bear with me. I know we've been saying a lot of stuff, but I'll tell you what, I'll make one up. Y equals 3x minus 2, and y equals 3x plus, I don't know, 4. All right? So what you're going to do is you're going to find, or you're going to construct, or draw the distance between these two lines. Okay? Write that down. Construct, okay, the distance, you can write the rest of it down, between these two lines right here. So what do you think we're going to do with those two lines? We're going to graph them, right? So let's graph those two lines. All right, this is something we did earlier in this chapter. You should know how to do now. And let's graph them. And let's do it in a different color. Let's go this pinkish, purplish color. Let's graph this first one right here. -2 is the y-intercept. So I put a dot at -2. The slope is 3. So what do? I rise 3, 1, 2, 3, and I run 1 right there. And then I connect the two dots, and I've got a nice line. Excuse me. So there's one line. Well, I got to draw this line as well, don't I? Construct it. 4. So my y-intercept is 4. 1, 2, 3, 4. So I put a dot right there. The slope is 3 again. So I rise 3, 1, 2, 3, and I run 1 right there. These are kind of close together, but you get the idea. Now, if you don't use graph paper, sometimes you might be off a little bit. It does look off a tad, doesn't it? Let's try to rig it a little bit so that it, there we go. That's good enough, right? They look kind of parallel there. So which could you do? You could do this. You have two choices. You can go from this point perpendicular here, or if you wanted to, you could go from this y-intercept perpendicular here. Or you could go any point along this. What I would do is this. I would go from one of your y-intercepts. It doesn't matter. This one or this one. So let's go from this point. And what do we have to make this? We got to make it perpendicular, don't you? Tell you what, I'll let you just eyeball it. Okay, I'm not going to make you tell exactly where that point is. That's a little complicated. So I'll just let you just eyeball it. As long as you put the perpendicular, then you'd be good. You'd be done. So what do you have to do on this problem? What you have to do is graph this, and then take one of these points, either from here, go perpendicular to here, or you could go from this y-intercept and go perpendicular to that. Is that all right? And I don't even care what that point is right there. Again, it's a little too complicated for you to figure that out right now. All I care is that you understand that the distance between two lines is the perpendicular line. All right? And that's what you're going to have to do. You graph the two lines, and then you show me that distance, put that little right angle symbol there, and then you'll be good to go. So you got 3 types of problems. That's the third type right there, where they give you 2 equations. But what's true about these 2 lines right here? They're always going to be what? They're always going to be what? Say it. Parallel to each other. How do you know they're parallel without even graphing it? Because they have the same slope, don't they? All right, you see it? They have the same slope, so you graph them both, and you just find the distance between. And then your other type of problem is going to be where they give you a point, and they give you a line, but they give you the line as 2 points, okay? So you plot the point, you plot the 2 other points, you make the line, draw the perpendicular. So that's your second type. All right, that was just like that. We did 2 examples like that. And then they'll give you a picture. Okay, the first part of it, they give you a picture and they say draw the distance from a particular point to a particular line segment. Sometimes you're going to have to extend that line segment out. It just depends. All right, so you just have to be aware of that. And then we had another one like this. Okay, so they give you a triangle, draw it from here to here, and you're good to go. All right. Now, they don't ask you to do this in the homework. They don't just give you some point and some line. We just did that to get us started so we understood the distance between a point and a line. All right? So if you can do those 3 things, that's what the homework's all about. Make sense? It's really not much math at all. You might do a little bit of math to find that perpendicular, do the negative reciprocal thing, but other than that, it's not. You're going to have to plot some points. You need to know how to do that. You need to know how to graph some lines as well. All right, so a lot of the stuff that we did earlier in this chapter, it's going to come back here, and you're going to have to know how to do it. All right, so it's a worksheet, section 3.6, and I think it's page 41. Yeah, it says page 41 at the bottom. So you'll get one today, but if you happen to leave it in your locker, lose it, or your dog ate it, or whatever, you can always go to the digital lockers, print it out. It's the one that says page 41. Okay? That's it.